Today we're going to talk about the zero property for exponents. The zero property of exponents states that anything raised to the zero power is the number 1. Often we see this combined with other properties of exponents, such as the product or the power or even the quotient rule. Here is an example. You can see that everything in the parentheses is raised to the zero power. Remember, we said anything raised to the zero power is 1. That means since the entire parentheses set is being raised to the power of 0, that means the entire parentheses set is just equal to the number 1. The second sample here, we have a little bit more going on. We have a 3 out front, then we have an x to the 0 and a y to the 4th. So here, the 0 power is only applied on the x. And so that means that this portion of this example is equal to the number 1. So we're really looking at 3 times 1 and then y to the 4th. And 3 times 1 is 3. And so you're getting 3y to the 4th there. For the third one, it says when combined with the power property, we distribute the power to everything in the parentheses and work the problem from there. So here you can see that the power of 2 is being applied to the coefficient of the 3, to the x squared, to the y to the 0, and to the z cubed. So here 3 squared is where you're going to get the 9 from. Y to the 0 times 2, we know that 0 times 2 is going to be 0, and y to the 0 power is just the number 1. And that is where that number 1 is coming from. And then z to the 3 times 2 is the 6. And then 9 times 1 is just the 9, and then the z to the 6 is next to it. And so that's what's happening in that example. Let's look at a few together. So here we have a 0 power, and where the 0 power is showing up is just on the y right here. So we are going to need to work with what we've got here. We've got more going on. I have parentheses here, but I do not have a power outside the parentheses. So the parentheses set here is actually good to go to move forward. And we're multiplying these two expressions together. So for our coefficients, we have a 4 and a 2. Remember that the coefficients are going to multiply together. So 4 times 2 is going to give us 8 out front. The next thing we have is we have x's. We have x to the 5th and x to the 6th right here. So x to the 5th times x to the 6th is going to give us that common base of x. And then remember, you're multiplying, so you will add your exponents. So that's what I will deal with for those x's. Remember, we just are learning today that anything to the 0 power equals to the number 1. So the next thing we have is just the number 1 for that y to the 0. And then the z to the 4 doesn't have any other common bases, so z to the 4 is just going to stay like it is. So now we're going to simplify this. So 8 and the 1 are now like coefficients, and 8 times 1 is 8. For the base of x, I had 5 plus 6, which is 11, and then z to the 4th. And that's the answer. Forgive all the coughing. I have some really bad allergies right now. I think it's been 6 weeks I've been coughing. The next one here, we have a product again, and we have a power to power going on. This is one of my favorite types of questions. As you can see, there is a 0 power, and that 0 power is being applied to the entire set of parentheses. So we're going to look at everything that this applies to. Everything that I just highlighted in pink has the power of 0, which means that all of that is just going to be the number 1. So what we're really doing here is we are multiplying the 3x squared times 1. So really it's just like having a coefficient of a 3 and a coefficient of a 1, and 3 times 1 is 3, and so 3x squared is the answer. I love that kind because they always look really scary, and then when they end up being so easy to do, it's exciting. This one here, we have power to power. We do have a 0 in there. It's showing up on the x here. But the first thing we're going to do is apply that power to power rule. So let's see how many pieces we've got. We've got the 16, we've got the x, we've got the y's, and the z's. Remember, when you're doing power to power, you are multiplying. So the coefficient here doesn't currently have a power. It's like having a power of 1. So its new power is going to be the power of 1/2. So 16 is going to have the power of 1/2. The x has a power of 0. And remember, we are multiplying times 1/2. And then we have a y, and its current power is a 4, and it's going to be multiplied with the 1/2. And then the z has a power of 12, and it's going to multiply by the 1/2. So now we're going to look at what all of this does. So we have 16 to the 1/2, which we could go over here to Desmos and look at what 16 to the 1/2 is. So 16 a to the b, 1 divided by 2 to get that half power, and it's a 4. So the 16 to the 1/2 power is a 4. 0 times anything is 0, so this is going to have a power of 0. And x to the power of 0 is going to be a number 1. Next, we have y's. 4 times the half is 2, so the power on the y's is a 2. And then for the z's, 12 times the half is 6, so the power on the z's is a 6. The last thing is just to simplify. 4 times 1 is 4, so 4y squared, z to the 6. And our last one. So here we have a quotient, and within the quotient we do have a 0 power here on the y. So we're going to simplify where we can. I'm first going to look at my coefficients, the 6 and the 3. Those are going to simplify like a fraction. And then the x's will simplify, and then the y's, the only thing that I have with the y is actually the y to the 0 on the top. So I'm going to copy my fraction bar here. 6 and 3, they're like having 6/3, would reduce to 2 over 1. So I can write 2 over 1, or I could just write 2 on the top. So the top is just going to have a 2. Then for the x's, where are there more and how many more? There's more on the bottom. And then 4 minus 2 is 2, so there are 2 more x's on the bottom. So the x's will be on the bottom, and the power for them is a 2. Next is the y, and we know that anything to the 0 power is a 1. And so this is like saying that I have a times a 1 on top. 2 times 1 is 2, so 2 over x squared is going to be the answer for that one. And that's our 0 powers.